Oh, now we're going to do trig stuff. So let's start with sine. So once again, we're going to go back to the limit. Limit as h goes to 0, sine of x plus h minus the sine of x all over h. Now, back in pre-calculus, you hopefully studied trig stuff, and this is a sum or difference of sines. And so, if you remember that, you'll be able to expand this. If you don't remember that, then you better look it up. So, sine of x plus h is sine of x cosine h plus sine of h cosine x. And then minus the sine of x all over h. Well, let's see. You may not have an idea what to do. Look for things that look alike. So if I look here, and I look here, I see a sine of x. So let's slam those together, but pull out the sine x. So sine of x, limit as h goes to 0, cosine h minus 1 over h, plus the limit, I ran out of room, sorry. I'll just do that. The limit, I don't want the limit yet, that's why I paused, silly me. Let's take that cosine out. Cosine x, and then the limit as h goes to 0, sine h over h. And let's see. So on this page I gave you this graph, and that graph is the sine of x over x. Once again, as we approach 0, we're going to 1, just as with that e function that we had last time. So this is going to equal 1. I forgot to give you this one. I believe it's on the next page, but we will see on the next page that this equals 0. Once again, if we actually plugged in 0 for h, we would get 0 over 0, so we would have a problem. But if we look at the graphs, then we're in good shape. So what we just figured out is the derivative of the sine is the cosine. And see, I told you that cosine x minus 1 over x was there. But how about cosine? So if the limit as h goes to 0, if we have cosine of x plus h minus cosine of x all over h, I'll try to do better with my spacing this time, don't worry. Well, you should worry because I'll probably mess it up. The limit as h goes to 0, now these are cosine sums and differences, so that's going to be cosine, wow, that was a terrible cosine, cosine x cosine h minus sine x sine h minus cosine x all over h. I want you to finish this one. I'll tell you where you're going to get. You're going to get to the derivative of the cosine is the negative sign. See if you can get there, and if you can't, ask me about it. And I won't answer you, but hopefully one of your peers will. Now, once you have the derivative of sine and cosine, you can find all the others. So, I'm asking you to build all the others. I'm going to do one for you just to show you what I mean. So, suppose I have y equals the secant of x. Well, that's the same thing as y equals, do I want to do quotient rule or chain rule? I'm going to do chain rule. That's 1 over cosine x, so you could do quotient rule there, or you could think of it as cosine x to the negative 1. So if I take the derivative of y now, so dy dx, that's to the negative 1, so it's negative 1 cosine x to the negative 2 times the derivative of the inside, which is negative sine, because the derivative of cosine is the negative sine. So that's telling us that dy dx is going to be, the negatives will cancel, sine x over cosine squared. I'm writing it twice, because now what I'm going to do is I'm going to write it in terms of how it started to make it look a little prettier. If I think of that as sine times 1, that right there is the secant. And then if I think of that, hopefully recognize that as the tangent. So what we just figured out is the derivative of the secant is the secant tangent. Be careful when writing the secant that you don't forget the c. It gets super awkward. So just be careful. And try to prove the other ones. So you're going to prove tangent and cotangent and cosecant. And try to get them into a pretty form like this. See if you can do it. Ask questions if you cannot.